the heart of the solar system, mysteries and the end of the sun. The silent giant. Look at the sky. There it is, the sun. For us, a constant presence, a golden disk that marks the beginning and end of our days. But have you ever stopped to think about what is really happening up there? 150 million kilometers away, there is a nuclear furnace so violent and complex that it defies our imagination. The sun is not just a star. It is the gravitational anchor of everything we know. Without it, Earth would be a wandering block of ice in the black vacuum. But the sun is also a monster, a sphere of plasma that consumes 600 million tons of hydrogen per second. In this video, we will delve into the deepest layers of our star, understand how it creates light, how it protects us, and, most importantly, how it will one day destroy everything it has created. The scale of the monster. To understand the sun, we first need to understand its size. We often hear that the sun is big, but abstract numbers are difficult to visualize. Imagine that the Earth were the size of a small grape. In this scenario, the sun would be a sphere almost 2 meters high, occupying an entire room. In terms of mass, the sun holds 99.8% of all the matter in the solar system. This means that if you put all the planets, moons, asteroids, and comets on a scale, they would be just a tiny speck of dust compared to the weight of the sun. This colossal mass is what generates the gravity necessary to keep giants like Jupiter and distant worlds like Pluto in their orbits. If the sun disappeared now, we wouldn't just be in the dark. The Earth would be launched straight into deep space at 30 kilometers per second. The nuclear engine. How does the sun shine? Many people think that the sun is on fire, like a giant bonfire. But in space, there is no oxygen for combustion. What happens there is something much more powerful: nuclear fusion. In the sun's core, the temperature reaches 15 million degrees Celsius. The pressure is so overwhelming that hydrogen atoms are forced to fuse, transforming into helium. In this process, a small fraction of mass is converted into pure energy, following Einstein's famous equation, E=mc². This energy is released in the form of gamma-ray photons. But here's the most fascinating fact. A photon created in the center of the sun doesn't immediately fly off into space. The sun's interior is so dense that light keeps bouncing off atoms like in a frenetic pinball machine. This journey, called a random walk, can take between 10,000 and 170,000 years. This means that the light that warms your skin today was generated around the time the first modern humans were beginning to migrate across Earth. The solar anatomy. The sun has layers like a fiery onion. In addition to the core, we have the radiative zone and the convective zone. It is in the convective zone that plasma rises and falls in gigantic currents, like boiling water in a pot. Above that, we have the photosphere, the visible surface that emits the white light we see. But the strangest part is the solar corona, the outer atmosphere. In any common logic, the farther you get from a heat source, the colder it gets. But on the sun, the surface is at 5,500 degrees, while the corona, thousands of kilometers away, reaches millions of degrees. Scientists still debate exactly why this happens, but it is believed that magnetic fields whip the energy outward, superheating the atmosphere. The shield and the sword, solar wind and magnetism. The sun is an extremely magnetic environment. This magnetism creates sunspots, cooler areas that look like dark spots. When these magnetic lines twist and break, they release solar flares and coronal mass ejections. These explosions launch billions of tons of charged particles into space. If one of these storms hits Earth at full force, it could fry our satellites, knock out global power grids, and destroy the internet. On the other hand, the sun also protects us. It blows a constant bubble of particles called the heliosphere. This bubble acts as a shield, deflecting dangerous radiation coming from other stars and the center of the galaxy. We are literally living inside the sun's extended atmosphere. The final destiny, the end of everything. Stars don't live forever. The sun is halfway through its life, at about 4.6 billion years old. It still has fuel for another 5 billion years, but the end will not be silent. As the hydrogen in its core runs out, the sun will begin to burn helium, becoming a red giant. It will engulf Mercury and Venus. Earth, if not engulfed, will become a scorched desert where the oceans will boil and evaporate completely. Eventually, the outer layers of the sun will be so meadows into space, creating a beautiful planetary nebula. What will remain at the center will be a white dwarf, the dense, cold corpse of our star, the size of Earth, shining faintly for trillions of years until it fades into total darkness. Conclusion: our mother star. The sun is a constant reminder of our fragility and our luck. We are a small blue dot orbiting a perfectly balanced nuclear power plant. Studying the sun is studying our own origin, because every atom in your body, the iron in your blood, the calcium in your bones, was forged in the heart of stars like this one.